Hi, today we are going to take a look at another aircraft instrument. So this one is an exhaust gas temperature indicator from 0 to 750 degrees. Okay, we can see the power supply indication here, 115 volts AC. There is a manufacturing date, 43.2, maybe 82. We see the date code inside. So this thing was manufactured by SC ADS Incorporated. The thing is very nice. There is here a servo control assembly. There is a dual gang potentiometer, a small DC motor, and a gear train. We can see here the solenoid for the flag. And here we have two boards and this small module, which is a cold junction temperature. Okay, we can see on the rear here we have two different pins here. So this is the thermocouple input. It's normally a K thermocouple, so we should have alumel and chromel alloys here. The junction is done inside this module, and the temperature of the junction is measured. We can see the thermocouple input wires here. It is difficult to access to the board. I think that the best solution is to remove this long spacer here. Over there we have the power supply. Here there is a 79L05. This is a minus 5 volts regulator. And here we have this module, metal can, date code 82. And this module seems to be the servo amplifier for the DC motor here. This is IST. This is the power supply and the servo amplifier board. You can see that this part is not populated. It should be possible to regulate also the positive voltage, but you can see that there is a short circuit here. You can see the positive terminal of this capacitor, which is connected here. So this seems to be the positive power supply line. Okay, there is also a ceramic filtering cap here. And here we have the analog front-end board. The ICs are socketed with low-cost sockets. First we have here an AD584, so this is the reference voltage. I don't remember 5 or 10 volts. An AD521, this is an amplifier. And we have here a classic dual pump. It's a very simple design. The use of such module permits to simplify the design, otherwise you need another board for the servo amplifier. Okay, we can see the ferrite beads here for EMC. So this small module was manufactured by Consolidated Ohmic Devices in Bridgeport. This thing is very well constructed. You can remove the board, as you have seen, without desoldering anything. Thank you very much. It is not always the case. No, I didn't see that there is also a spring here. This avoids the backlash of the feedback potentiometer. This is a schematic diagram of this unit. The thermocouple input is here on the left. It is fed to this cold junction compensation circuit, which is supplied with a voltage of 5 volts, which is the output of this voltage reference AD584. This voltage is amplified by this differential amplifier. The gain is defined by the ratio of these two resistors, 100K and 666 ohms. This gives a gain of 150, corresponding to a voltage of 4.65 volts for a temperature of 750 degrees. This voltage is fed to this interesting circuit At the non-inverting input here, there is a voltage of 50 millivolts approximately. When the input voltage here is above this value, therefore there is a negative voltage at the output here. Therefore this diode is reverse biased, and in that case the voltage at this point is identical to the voltage at the output of this amplifier. Otherwise, if the input voltage is below this voltage, which corresponds to a temperature of 10 degrees approximately, so therefore there will be a positive voltage at the output. Therefore this diode will be conductive. There is a negative feedback here, so this permits to have a new differential voltage here. So therefore there is a clamping at 50 millivolts here if the input voltage is below 50 millivolts. So this permits to have a voltage as input of the servo control system here above 0, because you can see that this is a feedback potentiometer which is supplied between the ground and 5 volts reference voltage here. So therefore the voltage at the input should be always a little bit above ground, otherwise this servo loop will never be controlled if the voltage is close to 0 here, and therefore the motor will run continuously. The servo control amplifier is a part of the hybrid circuit. The second part of the hybrid circuit here is used for the flag, which is present here. For the test, this indicator is connected to this thermocouple simulator. Let's turn on the lighting first. Now let's activate the AC power supply. It is not perfect, but it is not so bad. That's all for this indicator. Thank you for watching and see you next time for another video. Bye bye!